Hello, this will be an instructional video on how to program the AMI003 processor board and also run a functional test. We'll see how this goes. We may break it up into two videos depending on how long I can talk. So what we have here is this is the programming breakout board and setup. On it are the power button, and so this goes from pin 56, and it's marked with a blue square there, over to one of the power pins. Right now it's on pin 8, but 4, 8, 2, and 6 are all the same. And generally for all the testing I've been doing, I've just been leaving it closed, so it's just on. But I have a nice power supply that has a on and off button over here. And the power supplies are just clipped on to pin 2 for power and pin 3 for ground. And this other cable is our USB interface used for all the programming. And on it in particular, black at the cable goes to yellow, which goes to pin 3 for ground. Green, which is D plus for USB signal, stays green and goes to pin 11. And the white, the negative data pin, turns to blue and goes to pin 9. So we can leave this. We do not have the power plugged in there. We like using the power from the power supply. So we can leave that plugged into our hub, which goes to the computer we'll show in a second. And the second programming part that we need is the JLINK, which programs the LPC4330. And we can plug that guy in and leave him there as well. Over here I have a stack of new unprogrammed boards and some that I've already programmed and will run through functional tests, but we'll go through a new blank board first. The rest of the setup here, we'll come back to this later, but this is the functional test setup, which includes a sensor from Seek Thermal, a display board, this is the AMI007, and the system flex AMI011, and a USB flex that's been modified with a USB cable, and that's the AMI012. This is the actual computer we'll be sending over to you guys. So we'll be demonstrating it on the computer that you'll have. So the first thing we're going to do is take a board, and there are two similar looking headers on here. This is the 8-pin Molex FFC connector. This is the 10-pin. This is for other debug. For the programming the LPC4330, we'll use the 8-pin here. So you may want to get used to plugging these in. It happens quite a bit. I am putting an extra one of these white tapes into the box to ship to you. It goes in pretty snug, about that far. You'll be able to tell. Ensure the power supply is off. On this one we have it set to 3 volts, 2 amps max. Anywhere between 1 and 2 amps is fine. After that is in, we plug in to the breakout board. These are the 80-pin DF40s. And that guy's good. As soon as we power up, notice about 230 milliamps for a brand new board. On the USB hub, you'll notice that the green light came on. I'll power down so you can see it turn off and on. That means that the USB port is good on the V3 chip. We'll come over to the computer, and the first thing I like to do is open the DMESG monitor. So that's the system monitor for this computer, and that will just keep a nice running log to make sure, give you status on when things plugged in and out, and let you know how things are going. What you see here is the last time we plugged in the USB, it enumerated. I'll power down and power back up so you can see that happen again. See, it shows it's disconnected, and there it comes up good again. So you can do these in any order, but I like to start the longer process first, which is programming the V3. The password for this, and I've written it here on, is 3 lowercase p's, so P, enter, and you'll see it says initializing and it's off and running. The second chip, the LPC, just double click this guy, and you'll see it will start, and that guy's already done, so not in a rush to do him. You can press any key and that will go away until the next time. And now we're just waiting for this guy. So the first thing it does is it puts in a little bit of code to bring up a network interface and rename the ETH0. That's the sign that you want. And now it's programming and writing a whole bunch of memory to eMMC. Right now it's about 250 megabytes, so it takes a little bit. We're looking at about 2 minutes right now. We'll look to quicken this up as we go along here and send updates over to the computer. Please ensure that this icon is still on the computer. This is for TeamViewer, so that it would allow us to log in and do upgrades to this and help things like we want to speed this process up and help it write faster and get through boards faster. So now we're just going to wait a little bit. And if you're watching this on YouTube, you can fast forward till you see something change. Now you see the message is changing, and when the done sign comes up, it's done. You can close the window. We'll come back to the setup. We'll power down, disconnect the board, unplug the flex, and this guy is good, ready for functional test. We'll do one more board here, so you get a baseline of how long this process takes. Power on. Back to the computer. PPP, enter. Start the LPC. And we're wrapping it up. Done. Close the window. Come over to the setup. Power down. Disconnect. Okay, next we're just going to go straight into doing the functional test. We'll push this a little bit to the side. As we talked about before, this is the display board with the system flex and the USB flex and simulated battery cable.